So in this session, we'll be covering, well, I will be, it's not we, I guess, building a basic REST API, unit testing it, writing integration tests with DynamoDB local. I'll show you a quick comparison of the serverless tools that are available and go through why I use the ones I do. And then we're going to create some stuff with CDK. And then we're going to migrate what we've built into Lambda, and then into Fargate, and then also into the same code base into GCP, because we're at an AWS conference and that's what we do. The code, I'm going to be showing lots of code today, and you can grab it all on here, along with all of the slides and stuff like that. So you don't need to sort of desperately try and take photos of things. It's all going to be there. So if we're going to build something serverless, we need some kind of example. So let's pick a simple one, which is like, let's make a counter. You might have seen hit counters if you're alive in the 90s on the internet, that sort of thing. So to make a hit counter, we're going to have a REST API that has a GET request, and if you do /count/name, you'll get the count back. And if you post anything, any arbitrary data to it, you're going to increment that count. Pretty straightforward use case. So to do that, we're going to need a database and a REST API to do it. I like to start with hello world. I don't like to sort of use starter kits or go too deep in. I like to start from the base and work my way up. So I'm going to do this in TypeScript, even though I use a mixture of TypeScript and Go in my personal life and work life. To start a TypeScript project, you initialize an NPM package and then install all the packages that you need. So the only thing that we need at runtime is Express to run the HTTP side of things. And then we'll also need some dev time dependencies of TypeScript and TS Node, which is what we'll be using to run the application during testing, but not during production running. We need a database. The simplest database is to store some data in memory. You don't need a file or anything. So I've implemented here a database. So a database can be as simple as a map. So Redis is an in-memory map, if you like, with extra features. And that's what that is. You can get a value out, and you can put a value back in. So a straightforward in-memory implementation of the feature that we need to increment a number. And then you can create an API around it using Express. So you can say, well, create an app with Express. The second line there uses JSON, so it's going to simplify the code in that you can return a response, and it will automatically encode it in JSON for you. So here we've got creating the app, creating the GET request, which uses the database code to get the value and just chucks it back out the other side. Very straightforward HTTP handler. And the same goes for the post. It's just going to increment using that database. And then finally, it starts listening on port 3000 on the local host, just on the local computer. So with that, we've got basically the implementation. We've got a server we can run, and we can use TS Node to run that. Because we're using TypeScript has to be transpiled into standard JavaScript so that Node.js can run it. Typically, you might do that with the TypeScript compiler or a different transpiler tool, but TS Node simplifies that into a single operation, which is useful for when you're developing locally. And then we can test it with curl on the local machine, and we can check that things work. So once I've got the kind of basic thing in place, we can move on. And for me, that means writing tests. And the code at the moment, it starts up a full-blown HTTP server, right? It starts listening on port 3000. And typically with unit tests, what you want them to do is run as quickly as possible. And starting up a HTTP server and handling real requests slows things down. You have to wait for the server to start up and all the rest of it. So you can separate out the two parts of it, the server bit, the bit that actually opens up a socket, the bit that listens on the network, and the bit that does the HTTP code. You might hear people call that separation of concerns, this idea of splitting down code into separate modules or units. And then we can start up a testing framework. One of the most popular ones in JavaScript is the Jest framework. And along the top there are built in a bunch of dependencies. So bringing in Jest, the test runner, the type definitions for it, which TypeScript uses to provide autocomplete. And then ESBuild. So ESBuild is a JavaScript bundling tool. So like I said, we've got this concept of TypeScript, which needs to be converted into this JavaScript in order to run. ESBuild will do that step really, really quickly, much faster than, say, similar tools like Webpack or Parcel or similar kinds of JavaScript-based tools, partly because it's written in Go, but also because it's been designed for speed. And then a test library called Supertest. So to configure Jest to know that it needs to use ESBuild instead of using, instead of expecting JavaScript files, you need this configuration file. So this kind of bit of boilerplatey stuff, you'll need to use that in order to tell Jest what to do. But then we can start to write tests that match those desired behaviors. So when I'm writing tests, I like to write the tests so that they read as a sentence. So the thing that you're describing is the get handler, and then it returns the name and count as a JSON object. So the it is a bit of a clue of kind of how I think you should be writing those tests. And those match the requirements that we had at the beginning. So it should be a very sort of natural match from, I guess, your acceptance criteria, or whatever you're kind of working with on a day-to-day basis, and then the tests. And a lot of unit tests follow this kind of arrange, act, and assert pattern. So you're kind of setting up the test, setting up the environment for the test. In my case, I'm just creating that request to initialize the value. And then the act, which is the thing that you're testing, and then the assert, the checks to make sure that the things that you expected to have happen did happen. So that's a kind of typical flow, and it gives you this nice output. You can see, okay, all of the code is working pretty much as I expected, except I missed out a requirement. And if I look back to the beginning, I said that if there's a 500, if there's a database error, there needs to be a 500 status. Now, I think it's going to be really difficult for my database code as it stands to ever throw an error, because it's just an in-memory map. But let's go down that path and start to refactor that code now to be able to introduce errors whenever we want them. So to do that, we'll move that database code to its own module. So in JavaScript, a module is basically a file. So you can move it into a different folder, and you can start to structure your code appropriately. So I typically might have a database folder or something similar like that. And then I've exported a database class, which has this get and increment function, which you can see there. And then we can refactor the application to start being injected with that behavior. So how that looks is we have this idea here of the application being defined just as a variable within the file on the left-hand side. And then what we're moving that to on the right-hand side is it becomes like defined inside the function and returned by that function. And this is called dependency injection. It doesn't mean you need to start using some kind of complicated framework or making things really complicated. It just means a function that takes parameters. And in a typical serverless application, you may only have 5 or 6 dependencies that you have to wire up. It's not like you're having to create huge graphs of downstream dependencies. In this case, the dependency is the get function and the increment function, which match the type definition there, which is any function that takes in a string and returns a promise of a count, you can pass that instead of the database code. And what that allows us to do is, I'll go into that sec, but normal operation is pretty much unchanged. You create a database class, and then you push the implementations of the get and increment functions into your application. So you're changing the behavior of the application from the outside of your application. So the code structure is TS node. It runs the server TS. The server TS creates that new database instance, and it then passes that into the create app function. The app gets returned back, and then the server starts up the application and starts it listening. So you have this 3 different areas of concern: something related to databases, something related to HTTP handling, and something related to starting the HTTP server. And the outcome is still the same. We can do a count test, but we have this separation in our code and this ability to change the behavior of the code itself. So how do we force that database code to crash? Well, we can pass in an alternative implementation, and the alternative implementation could be any function that throws an error. It doesn't even have to take in a name, because JavaScript isn't particularly picky about the parameters. So as long as I start passing a function that throws an error, I can trick the code now, my database code, into crashing whenever the get or increment functions are called. And that's done by simply passing the function into the create application function. And of course, the test fails because I haven't actually implemented the functionality. So in test-driven development terms, that's called like red-green work, where you're you write a test to make the test fail, and then you write the code to make the test pass. And that means that you're pretty sure that the implementation that you wrote works. And in Express, the JavaScript framework for running these kinds of applications, at the moment, if you crash inside an asynchronous handler like this, it actually just times out, and what you'll see is your Lambda function may even just time out, because Express doesn't actually deal with that error. So at the moment, in the current version, you need to place a try-catch block around it and explicitly handle errors that might happen in your code. And at that point, we have everything we need. All the tests are passing. We've got a server. We can still do it with curl. We've validated all the behavior, and we haven't touched any Lambda functions. We haven't gone into the cloud yet. We're just sat on our machines. But we've got some kind of fake database. It's not very useful, is it? It's like, if you hit a Lambda function, the memory of that Lambda function can be persisted up to several hours later. So you can store memory inside a Lambda function, but if you hit a Lambda function concurrently, it'll start up 2 Lambda function virtual machines, and you'll get different counts depending randomly on which one that you hit. So we needed a separate data store to do that. So let's use DynamoDB. DynamoDB is a database that I've used a lot over the last 5 years on lots of different projects. So shipping 2 million prescriptions a month to pharmacies around the UK, selling lots of cars with some of the people in this room, selling lots of insurance policies recently as well, all ran on DynamoDB. And it has a super low cost of usage in those use cases, like somewhere in the region of $300 a month for all of our production use cases at sort of hundreds of thousands of uses a day. And it's pretty easy to manage, and it fits very well into that serverless ecosystem because you can switch it into this pay-per request mode. So when you're not hitting it in your test environments, you're not actually paying anything for that service. And in comparison to something like RDS, where you might be paying $300 for it to sit there and hardly have any usage at all, I find it to be quite cost-effective for a lot of use cases. But it requires a slightly different mindset on how you design a table. Perhaps not in this particular case, because it's a very simple use case. But we need to define our partition key and our count. So in DynamoDB, you define just the fields or the properties or attributes they're called in DynamoDB that define how you're going to query that data. So we have a name and we have a count, right? We want to get our count by its name, and we want to increment the count by its name. So a simple schema design would be to have the name as the partition key, and then have a count attribute which we can increment. So in DynamoDB, we can re-implement the same database interface that we implemented previously in memory, only we use a real database instead. So it's got the same. It's a class with the same functions or methods on it. So here we've got a get function, and we've also got a increment function, which adds 1 to the value. It's got this kind of funky if not exists thing, so you can do quite a lot of rich data manipulation with DynamoDB, not that you particularly will want to, but here we've got a line that says if the value doesn't exist, default it to 0 and then add 1 to it, but you can also use the add statement to increment simple numbers. And one of the nice features of DynamoDB is that if you update a record, you can get a free read result at the same time that you write the record. So I think in a SQL database, often you might do something like an insert statement, and then you might have to do something to get the output, or you might have to do a merge statement to make sure that you can read the output. In DynamoDB, you can mutate the data, and then you can get either the old version of the record before you messed with it, or the new version after you've updated it, or neither. And that's free of charge, so you don't pay any extra for that, which is free is my favorite price, so that's good. So I've written my database code, but it looks kind of complicated, right? There's these kind of weird statements in it. I'm not really that comfortable with writing DynamoDB. How do I know it's going to work? Well, let's write some tests. And this kind of testing is integration testing, because we really want to use a semi-realistic database, something a little bit more realistic than being in memory. And the workflow for that might be to create that table, use it, and then throw away the table at the end. And if you've ever worked with relational databases, you know it takes a bit of time to start up a database and populate it with data and then destroy it again. DynamoDB has a local option that you can use, and it's possibly the worst installation process I've ever seen, in that you just run Java at the command line and then execute a jar file, which is a pretty gnarly way to run a kind of core product. But it works. The alternative is Docker, which I think is way worse, right? I mean, because that means I would have to run Docker on my computer, which I try desperately not to do. And it doesn't even have an M1 version, so if you have a Mac, there's a bit of a workaround. But yeah, you can run it with Java. It works okay. But most importantly, it's fast because you don't have the network latency of going up to the cloud and coming back. So you can run your unit tests locally without having that latency of cloud. And the tests for this follow a pretty similar pattern of creating that local table, and then the create local table function returns both a DynamoDB client that's been configured to use the local database and also the name of that that table. So that finally, at the end of that, we can destroy the database table that we've made and clean up the test. So that means every test gets its own DynamoDB table. So you can be sure that tests are not affecting the outcome of other tests. And this is a pattern that I've used over the last few years at a few different organizations, and it's worked out really well for testing that layer of database work. To do that, we've got this test helper, which you can rip off and use if you find it handy. But the key elements there at the top are configuring to use the local host instead of the cloud, and then also returning that deletion function at the end so that you can clean up all of the wasted resources. And with those in place, that means you can kind of create these integration tests that validate that the database is working as you expect. So at this point, we've got two sets of tests which test each side of the application. We've got the bit that tests the HTTP handling function code. Does the GET request do the right thing in the right context? And we know that, on its own isolated, yeah, that's working great. And we also have this other side, which is testing the database specifically and saying, is that working how we expect? So with those two things in place, I feel pretty confident that when I put this in the cloud, anything that I've got wrong is probably my fault, right? Like it's probably something in the cloud side, not in the local application side. So, right, local app is working. We're using DynamoDB local, but we're still nowhere near the cloud. So it's only at this point that I actually start to think about running things into the cloud when I've got something that roughly works in my machine that has a little bit of enough logic to get started. So we've got a choice of infrastructure tools. I've used every single one of these tools to do something at some point. I've used Terraform to build all sorts of platforms and infrastructure since it came out first. I spent a long time using serverless framework, and it was great for a while. But Terraform, when it came to writing serverless applications, I found it a little bit wordy. Like there's quite a lot of individual resources that you have to construct in order to create a Lambda function. So when the serverless framework came out, I started adopting that and found that it was faster to get started. But there is a downside, and I've highlighted it in yellow, which is that it uses YAML. And I think YAML is the bane of our industry. And I think anyone who hasn't experienced an indentation issue, I'm happy for you. But has anyone not experienced a YAML indentation issue? No, I think everybody's in the same boat. So basically, I'll go quite some distance to avoid using YAML for pretty much anything. The serverless framework is based around CloudFormation, so it generates a CloudFormation template. And I would say that that's a bad thing because CloudFormation is really, really slow, and it has very poor kind of rollback, and it doesn't have anything like the drift detection as Terraform. SAM is basically the same idea, but it's written in Python, not JavaScript. And then we then got this kind of rush of new things in the sense of infrastructure as code, so using the same programming language that you're using to build your application, but using that to design to develop your infrastructure constructs instead. Initially, I avoided CDK because I'd heard bad things about it. I think what I've seen with serverless framework, the downsides that I saw were things like overusage. You run into some strange things like running out of Lambda function versions, and suddenly you need to search for a plugin to clear it down. If you want to have individual identity and access management roles per function, actually, you need to get a plugin for that as well. And if you want to do a lot of things, you end up kind of adding more and more plugins into the base element of serverless framework. And then at some point, you can run into this, you end up writing raw CloudFormation, and it's sort of ending up in this massive YAML stack. And then eventually, you hit the 200-item resource limit in CloudFormation, and then you're searching for a plugin again. So I was kind of not completely happy with it. And CDK came out, we gave it a blast, and it has reasonable high-level abstractions. So for the last few years, I've been all in on CDK for all of the infrastructure that I built. So the kind of new insurance company I've been working at, all of our stacks entirely in CDK, both in Go and in TypeScript. And, and also in Python as well. So all the data engineers are using Python to build their infrastructure. All the kind of back-end projects are using Go, and all the front-end projects are using TypeScript. And that means that people don't need to necessarily become Terraform experts in order to get their job done. They have to become CDK experts instead. So let's create a DynamoDB table. You need to install the CDK tooling and initialize an application. That creates like a rough template for you. And inside the lib folder is a stack. And you can start to add the resources that you want in there. And the key benefit of CDK here is you have the strong typing. So you have the ability to get autocomplete from your development environment. So it helps you to populate the required fields. And in addition, the defaults are generally sensible with CDK, although there are exceptions. So things like encryption are sometimes missing. You need to go in and add them. Sometimes it's set correctly. So you just need to take a little bit of care in which bits are required and which bits aren't. But to create a DynamoDB table, create an instance of the class, hit the billing mode, and then you can output the name as a CloudFormation output variable so that it gets printed to the console. So it takes a little while to create a DynamoDB table. Sometimes in the order of a minute, which is why it's not really suitable to use a real DynamoDB database to create and destroy multiple times during your unit testing. But you end up with a stack output. So CDK creates a CloudFormation template and then deploys the CloudFormation template for you. At this point, one thing that I sometimes see is people start moving their code in, but you can actually go a sort of intermediate step. Just because now that you've got a DynamoDB table in the cloud, you can use it from your local machine. There's no restriction on you doing that. So at this point, we can wire up our local application to talk directly to the DynamoDB that's in the cloud, so long as you have your AWS credentials in place. Because all of the AWS services like DynamoDB, these are they're not VPC based. They're not something that runs inside your VPC. They're just APIs on the internet like any other. So here we've got the same application that used to run with an in-memory database. If you have a table name environment variable set, it'll try and use the DynamoDB in the cloud instead, using the local credentials that are on your machine. So you can get quite far, again, testing your application locally without ever touching on the cloud. So the outcome then is, we've got a local server, using local credentials, connecting to DynamoDB and AWS, and we're just testing a local web application like it's 1998. All right, so let's move that compute to the cloud then. Let's get all of our Lambda functions in. Let's move the last piece. The Lambda architecture that we're after here is API gateway receives that HTTP request. It turns that into a JSON blob, and it posts that over to the AWS Lambda service. AWS Lambda gets it, and then starts up a container if it needs to, or virtual machine containing your code, and then sends your request, that request JSON over to the entry point. Your code does its work. It might connect to DynamoDB or make another API call or do something else, and then it returns a response payload back to the Lambda service, which forwards that back onto API gateway. Fairly straightforward. But the structure of your code kind of has to be a certain shape to fit within Lambda. So like Lambda is sending an event which is structured in a particular way. So we're going to receive an API gateway event, and it looks nothing like a HTTP request that comes from something like an Express app. So there's a sort of incompatibility between those two worlds. But you can plug that with an Express adapter, like serverless HTTP, and that turns your Express application into a normal, into a serverless application with just a line of code there. So that allows you then to have this application that can work in these two worlds. You can run it as a local Express app, or you can run it as a Lambda function inside AWS. And shortly we'll see that you can also run the code in GCP or as a Fargate container as well, if you follow these kind of ideas. And so why would you want to do this, right? Why would you not just go all in on using the Lambda side? Well, you might, but you're missing out sometimes on ecosystem benefits. So if you're used to using Express, or you want to do something like JSON logging of your HTTP requests and responses, in Express, you've got a load of stuff that's ready to go. Your team can use these kind of things that you're already familiar with. And so adding JSON logging is a case of importing the Morgan package and then customizing the formatting. You can also use things like authentication APIs for OIDC and other bits and pieces that you might be wanting to use. So now we've got our Lambda function entry point, which is simply wrapping the same code that we had earlier, just importing that application from one file, wrapping it in a serverless function, and returning it. We can create a Lambda function in CDK. And CDK has this high-level construct called a Node.js function. So if you typically, we said there's a couple of things we need to do, right? We need to transpile our TypeScript code and turn it into Node.js code so that we can run it inside a standard Node.js environment. Or you can use Node.js function and point it at the TypeScript file. And CDK will go, oh, right, that's a TypeScript file. I'll look up the directory to find the nearest npm package.json file, and then I'll run esbuild inside that. And esbuild will take that TypeScript file, look for all the dependencies, and bundle it together in a single file that you can then upload to, that it then uploads automatically for you to an S3 bucket that it creates for you to take care of everything else. So it's just, you can get away with a single line, but typically you would want to add some customizations to your Lambda function. So for me, I run all of my Lambda functions now as ARM64 rather than x86 instances because it's 20% cheaper, and I'm tight because I'm from Yorkshire, I guess. Maybe that's it. But you might also want to customize the amount of memory or increase the timeout. And if you don't have esbuild installed on your machine, inside that project or on your machine globally, CDK will attempt to use Docker. And as we've already established, I dislike running Docker because it uses the RAM on my computer and it wastes CPU. So instead, you can install the esbuild and it'll just run it locally instead. You don't need to install Docker. And then you can grant read and write access. So here we've also got this other brilliant feature of CDK, which is when you have a function, it implements something called like a grantable, which means that it has a kind of implicit identity and access management role. And by calling grant read write data on the table, we can then grant the count post function read and write access to that database table, which I think is a brilliant feature because otherwise you would have to understand how AWS identity and access management works, resource-based policies, and really get into some detail about how to construct the correct IAM role for that particular function. Or you can just call this one line of code and it kind of does enough for you. And this saves teams a lot of work. The work that I've been doing has been like multiple security audits, and one of the things that the penetration testers have found is that because we've really carefully scoped, each individual Lambda function has an identity and access management role that only gives it just the permissions that it requires. We don't just have like one big role that does everything, that has access to things it doesn't need to. Everything is quite tightly scoped, which reduces the blast radius of any single function. But we also need that API gateway, and again, it's a very similar sort of situation. We've got a HTTP API, and we can add routes into it. So here we're passing it the function, and then CDK understands the relationship between the two things, and it automatically infers that before I create the API gateway, I should probably create the function because the functions are required by the API gateway. You don't have to do any kind of depends on and kind of give it any hints about the structure or order of things. It can calculate that itself by creating essentially a graph of the dependencies. And then we can deploy it. And deploying creates a CloudFormation template and uploads it to CloudFormation, which we've already established is slow. Or should I say, I just asserted that it was slow. But you can also do a CDK deploy. Once you've done the initial deployment, it creates all of the kind of identity and access management roles, API gateway, Lambda functions, zip files, CloudWatch log groups, permissions, and all the rest of it required to make the application work. But you can also, if you've changed your code and you want to deploy again, you can use the hot swap command, and it will just upload the new zip files containing the code and skip the CloudFormation update stack. And that can give you a much faster cycle time. So the thing that I'm obsessed with development is how can I get faster feedback from what I'm doing? And for me, like the fastest feedback comes from unit tests, then it comes from integration tests, then it comes from kind of sort of test the real infrastructure like end-to-end or CI/CD. And sort of at the last possible case, I'll try and kind of actually deploy something and play with it manually because it just takes time. And so what I've sometimes seen is like people on a team make a change, go, oh, it's broken. I'll do another CDK deploy through the CI/CD pipeline. 10 minutes later, it's just about done. And then they go, oh, no, it's broken again. And before you know it, like you've wasted 2-3 hours on a really simple problem. If you can just get in there and do a hot swap change, you can get a much faster cycle time and get through those issues and get moving. It comes with a warning, of course, as not to mutate your production stacks in such a fashion. So, use with caution in your test environments. So when it does go wrong, you need to get the logs. And this is another kind of place where you see people wasting time, right? I need to get the logs. I'm logged in at the command line. I better go to open up a web browser and get over to the console, find the right log group and sort of search for it. Tools like SAM and Serverless Framework have log functions built in, but CDK doesn't have an equivalent, so you're kind of out of luck. So I was using this tool called SAW, which is by Tyler Brock, but it was slightly annoying because you have to remember, there's a few steps that you need to do. So I forked it and made it really simple. So you can take SAW get, the name of the Lambda, the name of the function that you created in CDK, -- fuzzy to do a fuzzy search, and it'll search for all the log groups and bring back the right ones and bring up the last 10 minutes. And you can also watch the logs coming in, and it provides coloring and all the rest of the kind of good stuff. So it can skip you from kind of having to go into your console and like look through your logs and stuff like that. So yeah, my speed tips are getting the app working really well first, using those unit tests for the fast feedback. I find Docker builds infuriatingly slow, so I try and avoid them as much as possible. Getting rid of things like Webpack and using ESBuild because it's way faster than the alternatives. I believe SWC is on the up and coming, but I've not seen it. I tried it out and it was a bit difficult to use. And yeah, try and avoid waiting for that CI/CD to deploy. What can we do to sort of bypass those processes? And then, yeah, don't bother logging into the console. So having said how much I dislike Docker and using it, let's migrate our application to Docker, right? Because it's just a local Express app, right? So now we can migrate it to Docker using exactly the same tooling. So to Dockerize it, we've got to create a Docker file. So typical best practice here is to use a multi-stage Docker file, like a bit that gets the dependencies. Don't try and read that, it's horrible, isn't it? Something that builds the code using the dependencies you've installed. And then something that creates that production container that doesn't have any of the development tools in it, that's just kind of minimized, and it doesn't run as root, it runs as a different user, so it's kind of got a better set of permissions than it would have had otherwise. And then, of course, this can be set to have a read-only file system, which is also best practice. There's so much best practice in this world, it's frustrating. But you can use CDK in the same way, and you can have this thing called Docker image asset. And much like the Node.js Lambda function, you can point it at a Docker file, and it will build the Docker file using Docker on your machine for the target platform that you wish to use. So again, typically these days I'm using ARM64 for Fargate tasks because it's cheaper. And it's relatively straightforward. I will say that what this doesn't have is a reasonable tagging strategy. So after happily using this for like 6 months, I looked. We did a security audit, and we found that there was something like 2,000 Docker images in our ECR repository, all with random names, many of which had critical vulnerabilities. And CDK just creates them with random with SHA-256 hashes of the contents, so you can't actually tell which images are in use and which ones aren't. So you may find that it gets you going quickly, but it's actually going to slow you down in the long run. So I ended up having to write some scripts which kind of hunt through your AWS account to find out which ones are actually in use. So be warned, some of these things look friendly, but they can bite you. So yeah, then you can create a task, and you can use our grant read write. So earlier we had this kind of individual HTTP handler level of implementation of IAM roles. Here we've got a Docker container that's doing 2 things, the get and the post operation. So we have to give it read and write across the container, not at the individual task level or HTTP root level. And then we can run it as a Fargate service, and it works, right? That's the same code that we had running in AWS Lambda, but also running in Fargate. The only difference is the entry point of the application is slightly different. Instead of having a Lambda function entry point, that bit where we wrap the function with serverless, we're just running the same application that we would run locally, but in the cloud. And that lets us also go multi-cloud with CDKTF. So CDKTF is a relatively recent addition to this. It uses Terraform modules, but accessible via the same kind of program environment that you would use with CDK. So every kind of resource in CDK becomes a class in CDKTF. But that also opens up the ecosystem that Terraform has around it. So Terraform has providers for GCP, Azure, Snowflake, all sorts of weird and wonderful things that you can do with Terraform. And GCP has equivalents of like AWS services. So Lambda can be substituted for Cloud Functions, and you can substitute Cloud Firestore for DynamoDB, roughly speaking. And because we've implemented a database class with just 2 functions on it, we can re-implement that using Cloud Firestore, which is actually pretty straightforward implementation. Create a Firestore database, and then either get it or increment it. And arguably, it's simpler than the DynamoDB equivalent. And then one of the nice things about Google Cloud Functions is they thought about the end user. And the default interface for a Cloud Function is an Express application. So you don't need to do any Express wrapping. You just pass it your Express application, and Google will happily run that for you. And that's the same whether you're using, in GCP, that's the same if you're using Go. You just run a standard HTTP server and so on. But yeah, same kind of behavior there. CDKTF is a bit more wordy than CDK on AWS because it doesn't have these higher level constructs. Things are much lower level. So you find that there's a little bit more work to do. So you're creating a Google provider, you're creating the App Engine application, which isn't really documented that you need to do that. There's no kind of specific Cloud Firestore. There's a lot of string types instead of kind of friendly types that are going to help you out. There's no equivalent of like, hey, take this Docker file and run it. You have to sort of you have to pass it itself. And then you can create these Cloud Functions in roughly the same way. So you have to build the Lambda function yourself, create that TypeScript, create that Node.js compatible output, and then point your Cloud Function at that. You can't get it to do you can't currently get it to do the build and packaging step in one go. But ultimately, it's rough. Once you're familiar with one concept of this, they're really adaptable between the 2 clouds. You've got the same application structure that you can move between these 2 worlds. So yeah, so hopefully what you're taking away from that is that if you structure your app to have this concept of the layers, it gives you a bit of flexibility in implementation detail. It gives you that ability to test at different layers at both the application layer and also kind of doing integration testing. And using these interfaces like Express allows you to benefit from this wider ecosystem that you may not have access to otherwise. And I think one of the things you hear about serverless a lot is it's just vendor lock-in, isn't it? I think hopefully you can see that it's not really that much lock-in. The lock-in really is around how much effort it takes to do configuration management and so on, and how realistic is it that you're actually going to move clouds or change databases? Hardly ever, right? I don't think I've ever actually heard anybody do it. But if if you're interested in CDK and you want to sort of get more hands-on with it, I'm going to run a workshop, hands-on, where you can try it out for yourself, supported by some of the great team over at InfinityWorks in the back corner. You can sign up there. There's a thing there. They're waving at you. They're keen. So yeah, if you want to come along to that, sign up at the back, and that's it. So yeah, thanks for coming here and not going over to Ben. That's great.
Okay, do you mind if I?
Yeah.
So we will get into questions very shortly,
okay.
And a round. In fact, let's start with a round of applause.
Thank you.
So we've got James Adcock, I think. Who's James here? There he is. Hello, James. Doing a talk next. We'll do Adrian's questions first. What I wanted to do was, so Sarah Hamilton, I'm not dragging people away from your talk. I wanted to give people the opportunity to switch tracks, if that's what you plan to do. Okay? Sarah will start in 20 seconds. One side, hand it back to Adrian to say, would you like to do your questions?
Yeah,
and then I'll come back in.
Has anyone got any questions then? Well, you can shout them out to me and I'll read and I'll say them out again if you like.
I'll run some back.
Well, first there has to be questions.
Don't see anyone. Oh, I've ruined the moment. Oh, come on. Someone's got out. There we go.
Hi, thanks
Hello.
for that. I found that sometimes with CDK you end up with so many IAM roles and stuff like that that you end up like, spamming your account and not having any more to do. If you're doing an IAM role for every single Lambda, does that happen a lot quicker, and is there anything that you can do to get around it?
Yeah, I think I get the general idea there. So you're saying there's like, if you have so many IAM roles, it's difficult to audit them because there's so many of them, right? And of course, a lot of them are just repeated, aren't they? Is that you? So a lot of the identity access management roles will be repeated. So in my world, a lot of the functions have the same capability, but you can define a role at the top and then reuse it throughout the same stack. And I think that's a completely reasonable pattern. In fact, it's something that we've done at one of our places where we've gone, hang on a minute, like all 50 of these Lambda functions basically do the same thing. Yeah, but that's what we've done there. Particularly around, also if you're running things in a VPC, sometimes you might have and you're using VPC endpoints or similar things, you might have like a shared role that you also apply to your Lambda function to give it like a base set of capabilities. But yeah, I think over abstraction in CDK is a problem. When people first see it, they start like overdoing it, start trying to break things up into too many places. It's definitely a problem that I've seen. Just have to keep an eye on it when teams start off and say, keep it simple, calm down. All right, I think that's it for questions. We've got another one. Hey, in the back.
Hi, great talk by the way.
Thanks.
I'm just interested to learn a bit more about the grant read-write table, grant read-write function on the table method, table class, sorry. Are you aware whether that's available on other classes for other resources like ECS, for example?
Yeah, it is available on a bunch of different things. So like I think S3, for instance, has similar kind of capabilities in that space. I definitely know that. I think it's SES doesn't. So it's kind of a bit patchy, but things like EventBridge definitely do, because those are the services that we're using. So yeah, it's a pretty common pattern throughout CDK. So what you'll find is like the level 1 constructs don't have it. They're just one-to-one mappings with CloudFormation, but you get these higher level ones that are more aware of it. And if you see something missing like that, a utility function that can help you, you can raise a pull request yourself, or you can create an issue in the repository, and then you can track it in there and then hope somebody gets around to doing it for you, basically.
Cheers.
Any others? I'll be around later for beer anyway, if you fancy having a chat. All right.